Now that we've taken a look at the streams implementation, let's go ahead and take a look at how you would do the same thing with RxJava. So as you know, RxJava is another implementation of reactive streams, and it has some interesting properties. It was one of the first reactive streams implementations in Java, and so it's based on Java 6, and that figures in a little bit because it can't use directly all the Java 8 classes like function and supplier and consumer, and instead has to basically make its own implementation of those things. Not really a problem in practice, but just something to be aware of. So down here we have the RxJava run flat map test, and we're going to pass in the download and store image BT method so we can reuse that one from before. And in this particular case, we're going to do this using the IO scheduler from RxJava. Now, all this stuff is going to be covered in much more detail in later weeks in the course, but for right now, just be aware that the IO scheduler is kind of something along the same lines as the managed blocker stuff that we were talking about before. Okay, because it'll add more elements in. So let's go ahead and take a look at run flat map for RxJava tests. And as you can see, it takes a function that it's going to be using to download the files. And the driver program looks very similar to the one that we used before for parallel streams, in that we first do garbage collection, then we delete any images that are downloaded. So we start with a clean slate. And then we're going to go ahead and call the test download flat map method, passing in the function that does the downloading, the name of the test, and the scheduler. So here's test download flat map, and this will start to show some really cool RxJava features, plus a few other things I've thrown in for good measure just to make the code even more cool. So the main heavy lifter in RxJava is a class that's called an observable. And this week's videos talk a bit about observable. Observable is basically, you can think of it as a stream that can have 0 or more elements in it. And it can all be processed and run asynchronously, as you'll see here in a moment as well. So what we're going to do is we're going to create ourselves a function, which is called download and store. And download and store is going to take the URL that we have passed in here, and it's going to download and store it. And it's going to use something called from callable concurrent if. And from callable concurrent if is just a simple wrapper that I wrote to simplify the code. And what it does under the hood is it says observable from callable, which is an adapter function that transforms things that are non-reactive into things that are reactive. So it's going to go ahead and lazily take the item that we passed in, and then it's going to go ahead and compose it. Now, compose is a very interesting operator that's defined in RxJava that can be used to kind of add additional capabilities above and beyond the operators that come out of the box. And what we're going to do here is we're going to use yet another little helper function I wrote called concurrent observable if. And if we're running in parallel, it's going to return the common fork join pool. Otherwise, it's going to use the calling observable. And so what that's basically doing is if it uses the common fork join pool, then it's going to go ahead and subscribe everything to run on the common fork join pool, as you can see here. And this is using a very cool adapter mechanism that's built into RxJava that allows us to take external thread pools like the fork join common pool from Java 7, I think, and then integrate it in with what is used with RxJava, the scheduler framework. And by using this thing called subscribe on, this is basically saying, run all these operations in the context of the common fork join pool. And so that's what that's doing. This is going to say, download each of the files using the common fork join pool. And then down here, we're going to take the list of URLs. We already saw the list of URLs before. Remember, that was the stuff that was going to take the images that we had here and turn them into URLs. And so basically what we're saying here is create us an observable that will emit all the URLs. And then we're going to use a really cool idiom that's in RxJava, as well as also in Project Reactor, called the flat map concurrency idiom. And this is sort of the old school way, and probably the most common way, most popular way of getting things to run in parallel with RxJava. And Project Reactor also has something that's basically equivalent to this. So what we're doing here is we're saying for each of the URLs that was in that list of URLs that we've turned into an observable stream, if you will, take that URL and have that URL run in the background scheduler, and then go ahead and download and store the image. And so what that means is that each of these URLs will then potentially be mapped to a different thread or scheduled to be run in a different thread in the common fork join pool. So they're all going to be running in the background in that way. And whatever thread finishes downloading the last image will then come through this flat map concurrency idiom boundary, if you will, and it will then be collected into a list. So we'll end up with a list of files, which we've downloaded, and that comes back from collect as something called a single. A single is another important class in RxJava, and singles in RxJava are used to either emit 0 or 1 element. So either it works and you get 1, or it fails and you don't get 1. So we end up with a single to a list of files, and then we use a very important method that's in RxJava called blocking subscribe. And what blocking subscribe does is when everything's done running and processing everything asynchronously, we will wait here and then we will go ahead and print the results. Now, this particular test program doesn't use all the cool things I've added later in my frameworks, where we do the whole thing asynchronously and then use the then or the ignore elements method in order to get the results when they finish asynchronously. This is a synchronous conclusion to an otherwise asynchronous processing, and it's just done so that the test program is easier to write. But this will then start all the processing in this stream, this observable stream, and when it's done, it'll go ahead and print the statistics out saying how many images were downloaded in how many threads. So that's one way to use RxJava. And you can see it's actually very similar in some ways to the streams approach, but in fact, the streams approach is actually a little simpler because they build parallel processing into streams in a more streamlined way than we get with RxJava. What you see with RxJava, though, it's more flexible for other kinds of things besides what we are doing here. The next method I want to talk about in the context of RxJava is called test download parallel flowable. And this is another way to process things in parallel using RxJava. This is an alternative, perhaps more modern idiom for doing things in parallel. The first approach we saw used the flat map concurrency idiom, and this uses some features that are built into RxJava in a more fundamental way. And once again, we use this little helper method called from iterable parallel, which goes ahead and says, convert the collection that's passed in into a flowable. And a flowable is a newer variant of an observable that adds some extra stuff like back pressure and parallel computing. And so we convert this into a flowable, say, I want this thing to run in parallel, and I want it to run on the schedulers in the common fork join pool. So that's how we're going to run this. It's going to use the common fork join pool to run all the processing. So at this point, everything at this point is going to be running in the context of a helper class called a parallel flowable. And so each of the images will be downloaded and stored in the parallel flowable. So the parallel flowable will do all this stuff in parallel using things, I think they're called rails. And then when all the processing is done, we say, kind of merge everything back together again. We want to go from being in parallel to going back to sequential. So when we're finished, we're now doing sort of a join, if you will. And then we collect the results into a list. And then we use blocking subscribe to print out the results. So just another way to do things. It's arguably more clear what's going on when you use things like parallel flowables than it is when you use the flat map concurrency idiom. But I think they're pretty equivalent in terms of performance. We can check that out if we ran this test program in a more controlled environment without as much jitter, because of the fact we're also broadcasting over Zoom and using network bandwidth that way.